In this video, I want to talk about the current climate change and its effects on humans and other species. For this, I made a graph of the causes and many of the effects of climate change, so that I mention each of them at least once and you can get an idea of how all of these issues are related. Obviously, in a short video like this, I can't mention all of the aspects of climate change, and I can't discuss each topic, but in the material on the website, you can find links to many websites that explain many of these issues. As you know from the previous video, there have been many climate changes in the 4.5 billion year history of our planet. In fact, one could say that the climate is always changing. However, usually these changes are very slow, so that no difference is noticeable in the lifetime of an individual. When these changes have been very rapid in the past, this has always led to the extinction of many species, which is why we're so worried about the current rapid climate change. As you probably know, the current climate change is caused mainly by the emission of too much carbon dioxide and certain other gases into the atmosphere. Most of these emissions are caused by humans, mainly by burning fossil fuels like coal, oil, and gas for transportation, electricity, and heat. Deforestation also plays a large role. Trees store a lot of carbon, and when we have a net destruction of forests, we have an increase of carbon in the atmosphere. Trees are killed for many reasons, but the main driver of deforestation is that trees are being cut down and burned to create agricultural land, whether it is for local subsistence farming or global commercial agriculture, for example to grow soy, to raise cattle for beef, or to grow palms for palm oil. Livestock, especially cattle, are a large source of carbon dioxide and methane emissions. Nitrogen-based fertilizers lead to the creation of nitrous oxide, which is a powerful greenhouse gas. All of these factors cause the emission of too much greenhouse gases, also called heat-trapping gases, so that their concentration in the atmosphere is rising. This graph shows the concentration of carbon dioxide in the atmosphere on top of the Mauna Loa volcano on Hawaii. It is called the Keeling curve after Charles Keeling, who began these measurements in 1958. The concentration varies between the seasons, that's why the curve is zigzagging. The concentration is now constantly above 400 parts per million. This graph shows the carbon dioxide concentration in the past 400,000 years. As you can see, during this time it has always been below 300 parts per million prior to industrialization. You can also see the steep increase after about 1950. Even compared to the highest levels prior to industrialization, the current concentration is an increase of at least 33%. The higher the concentration of the so-called greenhouse gases or heat-trapping gases, the more energy of the sun is retained in the atmosphere and the fewer energy is reflected back to space. As a result, atmospheric temperatures increase. This is called the greenhouse effect. The resulting increase in temperatures is called global warming. The term has often been used as synonymous with climate change, but should really be restricted to the warming of Earth, because climate change entails more than just rising temperatures. The warming of the atmosphere does not happen evenly across the planet. This map shows the difference between the temperatures during the year 2015 compared to the average temperatures between 1951 and 1980. Orange and red colors denote an increase in temperature, blue colors mean a cooling in that area. As you can see, the northern regions of the planet heat up faster than those near the equator and further south. The Antarctic region and the northern Atlantic have even gotten a little cooler. The global average temperature has increased by more than 1.5 degrees Fahrenheit or 0.8 degrees Celsius. Some regions of the world have warmed more than twice this amount. This might not seem much to you, but in practice it makes quite a difference. It brings with it longer growing seasons, more days of extreme heat, fewer days of extreme cold, and more frost-free days per year. For some species, this can already mean the difference between life and death. A warmer atmosphere leads to warmer freshwater and warmer oceans. This is also part of global warming. In this graph, you can see the rise in global land and ocean temperatures since the year 1910. The temperatures are shown as temperature anomalies, meaning the difference between that year's average temperature and the average temperature between 1951 and 1980. How much more temperatures are going to rise in the future and how fast they are going to rise will be determined mostly by how much more heat-trapping gases we are going to release into the atmosphere per year. A warmer atmosphere and warmer oceans lead to a decrease in ice and snow cover around the world, be it the ice in the Arctic and Antarctic, or ice and snow on mountains around the world. Glaciers like this one are shrinking in volume pretty much everywhere on Earth. This is creating a feedback loop because less snow and ice cover leads to the Earth's surface warming up more, which again leads to higher atmospheric temperatures. Global warming leads to higher sea levels due to two factors. Firstly, melting of ice means that water turns from the solid to the liquid state and most of it ends up in the oceans, meaning that the total mass of water in the oceans increases. And secondly, warmer water takes up more room than colder water, meaning that whatever mass of water is in the oceans is going to take up more space than it would have at lower temperatures. Higher sea levels mean more frequent flooding of coastal regions. This is already being observed in many coastal areas around the world. Flooding has negative impacts on humans by the destruction of infrastructure. Some islands already had to be abandoned. In some cases, the flooding has led directly to the death of human beings. The decrease in ice and snow cover in the mountains can have negative effects on the water supply of humans. It has already led to water shortages in certain montane regions, for example in the Andes. Warmer oceans also lead to changes in the abundance and distribution of marine species. Just one of countless examples is that small increases in ocean temperature cause the phenomenon called coral bleaching, which looks pretty but leads to the death of the corals and brings with it the demise of entire coral reef ecosystems. Changes in the abundance and distribution of marine species are of course likely to have a negative impact on the food supply of humans. Another physical effect we see from warmer ocean surface temperatures are more and stronger cyclones, that is, cyclones with higher wind speeds and heavier rains. This will also lead to an increase in the damage to human infrastructure and a higher death toll. A warmer atmosphere also leads to the melting of permafrost, which is what we call the frozen soil in the Arctic. The melting of the permafrost releases some of the carbon dioxide and methane that was trapped in the frozen soil, thereby adding to the increase in carbon dioxide levels in the atmosphere, which is another feedback loop leading to the acceleration of global warming. Melting of permafrost also has a direct impact on humans because houses sink into the ground and roads become unstable. A warmer atmosphere also leads to changes in precipitation patterns. Dry regions get drier, wet regions get wetter, and the severity and number of extreme weather events like droughts, heavy downpours, inland flooding, storms, and hurricanes increases. In the regions that get drier, wildfires happen more often and with more severity. All of these changes in precipitation patterns, as well as the increase in temperature, lead to changes in the abundance and distribution of terrestrial species. In the extreme, this is leading to species extinctions. Changes in the abundance and distribution of terrestrial species have an impact on humans in many ways. Changes in temperatures and precipitation also influence humans directly, for example when humans die from extreme heat or lack of water, or when infrastructure and human lives are affected by inland flooding and by tornadoes. Another effect of a higher concentration of carbon dioxide in the air that is not as well known as global warming is the increase in the concentration of carbon dioxide in the water, which leads to a lower pH of ocean water. This process is called acidification. The change in pH has a direct effect on marine species that use calcium carbonate to build their shells or skeletons, because the lower pH value of the water causes reduced calcification rates in these species, meaning they have problems making their shells and skeletons, which can lead to their death. Because these species are food for other species, including humans, the reduced calcification rates cause changes in the abundance of other species, for example fish, and directly and indirectly affect human beings. So this was an overview of most, but not all of the effects that climate change has on our physical and biological environment. To summarize this graph, we have the emission of too much greenhouse gases as the cause of changes in the physical environment, and these have direct and indirect effects on humans and other species. Some changes caused by climate change can be positive for humans, some depend on the view, but most are negative. To summarize the impact on humans, climate change can lead to a decrease of food supplies, a decrease of available water, decreased health, and damage to infrastructure. All of the above can lead to suffering and death of human beings, as well as wars and mass migrations of hitherto unknown proportions. The effects I've described in this video are not scenarios of the future. It is what is happening out there now, and it's just going to get worse. The discussion of how bad it's going to be and how fast is irrelevant to climate action. We know that it's going to get bad. The discussion of whether it's going to get bad or really, really bad, I find futile in this context. Animals, plants, and human beings are already being negatively affected. Corals are dying around the world. Species are going extinct. Humans are already suffering and dying because of climate change. How much worse does it have to get so that all of us are finally going to do something about it? We have to do as much as we can, and now. And what it is that we can do, I'm going to discuss in Module 8. I hope to see you there. Bye.